Good day everyone. In this lecture we'll talk about selective catalytic reduction or SCR technique. This is an important technology, as we've said before, widely used to reduce harmful emissions, especially in diesel engines. Let's dive into what SCR is, how it works, and why it is essential for our environment. To begin, let's understand what SCR actually stands for. SCR or selective catalytic reduction is an emissions control technology designed to reduce nitrogen oxide or NOx emissions from diesel engines. NOx gases are harmful pollutants produced by high temperature combustion in engines, and they contribute to smog and acid rain. By using the SCR process, we can significantly lower the amount of NOx emissions that diesel engines release into the atmosphere. Central to SCR is a substance called diesel exhaust fluid, or DEF. DEF is a solution made of urea and deionized water. When injected into the exhaust stream, it helps convert dangerous emissions into harmless substances. The injection of DEF is a crucial step as it initiates the chemical reactions needed to neutralize pollutants. So, how the SCR process works. Let's go through the SCR process step by step. The illustration we have here breaks down this journey effectively. First, exhaust gases leave the engine. These exhaust gases are filled with pollutants like nitrogen oxide NOx, carbon monoxide CO, hydrocarbons, and particulate matter. Each of these pollutants has adverse effects on both human health and the environment. Before SCR takes place, exhaust gases pass through a particulate filter. This filter captures the particulate matter or soot, preventing it from being released into the atmosphere. Particulate matter can cause respiratory issues, so removing it is an essential first step. After passing through the particulate filter, DEF is injected into the exhaust system. When DEF encounters the hot exhaust gases, it breaks down into ammonia NH3 and carbon dioxide CO2. This ammonia plays a crucial role in the next stage. Exhaust gases enter SCR catalyst. Next, the exhaust gases and ammonia mixture pass through the SCR catalyst. This is where the real transformation happens. The catalyst speeds up a chemical reaction where ammonia and the nitrogen oxide NOx interact to form nitrogen N2 and water H2O, which are harmless. Nitrogen makes up about 78% of the air we breathe, and water vapor is naturally present in the atmosphere, making them safe in the products. Reduced pollutants exit the tailpipe. After these reactions take place, the reduced emissions, now primarily nitrogen and water, exit the tailpipe. As a result, the SCR process ensures that fewer harmful emissions are released into the environment. Now let's take a closer look at the chemical reactions involved. Here is a simplified explanation of what's happening on a molecular level. When DEF is injected, it decomposes into ammonia and carbon dioxide. The ammonia then reacts with nitrogen oxide in the SCR catalyst. These reactions convert nitrogen oxide NO and NO2 into nitrogen gas N2 and water vapor also H2O. This transformation is vital because nitrogen oxides are highly toxic and contribute to environmental issues like smog and acid rain. Converting NOx into harmless nitrogen and water greatly reduces the impact of diesel engines on air quality. The primary benefit of SCR is its effectiveness at reducing harmful emissions. Significantly lowering NOx emissions, SCR technology helps improve air quality, which has positive effects on human health, especially for people in urban areas or near highways. Furthermore, by using SCR, industries can comply with stricter environmental regulation without sacrificing engine performance. Many countries now mandate SCR technology for heavy-duty trucks, buses, and other diesel vehicles to meet their emission standards. So, why SCR is important for the future? Looking ahead, the role of SCR technology is likely to expand as countries set even stricter emissions targets to combat climate change. The demand for technologies like SCR will grow, while SCR currently focuses on reducing nitrogen oxides. Advancements in technology might allow it to tackle other emissions as well. Moreover, as we continue to explore cleaner energy sources, SCR could be an important part of hybrid or transitional technologies until we fully adopt zero-emission vehicles. While SCR is highly effective, it does come with some challenges. First, the SCR system requires a constant supply of DEF to operate effectively. If DEF runs out or isn't refilled, the system won't reduce NOx emissions, which could lead to regulatory issues and affect vehicle performance. Second, adding SCR systems to vehicles can increase costs. However, many manufacturers and fleet operators view it as a necessary investment, as it helps meet emissions regulations and can lead to longer-term savings due to fewer fines and better fuel efficiency. Third, in some cases, excess ammonia can pass through the system without reacting with NOx, a phenomenon known as ammonia slip. Ammonia slip can result in its own emissions issues, but manufacturers often include controls to minimize this. To summarize, SCR technology is a crucial advancement in reducing environmental impact on diesel engines. By converting harmful nitrogen oxides into nitrogen and water, SCR makes diesel engines much cleaner and safer for both humans and the environment. This technology supports regulatory compliance and promotes better air quality, playing a vital role in our transition towards cleaner energy sources. In the future, as emission standards become stricter, SCR will likely become even more widespread. It's a critical tool in the fight against air pollution and a step towards a healthier, more sustainable world. Finally, thank you for your attention, and I hope this lecture has given you a clear understanding of how SCR works and why it's so essential.